Welcome back, Oceans and Carbon Cycle video part 2. You may have been thinking, Huffman, you left out the part where how does the carbon go from the air into the oceans? Good question. This is what we call the ocean uptake of carbon. Ocean uptake of carbon, meaning the ocean absorbs carbon from the atmosphere. Smiley face in red. We've highlighted in red because this is a carbon sink. This is pulling carbon out of the air. It happens through a process called diffusion. Diffusion is a passive process, meaning there is no energy necessary to make this happen. What happens is there is an area where there is more of some particular particle, these orange dots in this case. Then there is an area where there are less of these particles. And what happens is the area with the more particles, they just kind of wiggle around and move until they find themselves in the area where there was less. So in the result, we get the even amounts of particles on the top and on the bottom. That is what diffusion is. This can happen. Diffusion happens with liquids or with gases. This is happening with gaseous particles in the atmosphere diffusing into the liquid of the ocean. So the ocean passively absorbs carbon dioxide into the water. So here's these red arrows showing us that it's, sinking into the ocean, passively being absorbed through diffusion. And the more of the carbon dioxide we put in the air through factories, powering things for electricity, vehicles, and whatnot, the more carbon dioxide we put into the air, well, the more carbon dioxide the ocean takes in. Yay, thank you, ocean. Happy, red, yay, red for taking it in. All right. Now, we can also take a look more at this as the ocean uptakes the carbon dioxide. And we have the solubility cycle that just has to do with diffusion. There's also the upwelling we talked about that brings nutrients up to these surface waters here that also carry carbon in those nutrients. And then we have very productive surface waters here doing photosynthesis and pulling more of that carbon into organic storage in the oceans. This is awesome. Now, there's always that thing where the scientists have to pull out the bad news. Wait a minute. No, I'm sorry, I'm not to the bad news yet. Just kidding. Okay. As the carbon comes into the ocean and is taken up by all of the green stuff here, it eventually, with the carbon dioxide and the water, forms this thing called carbonic acid that then bonds with a hydrogen ion and gives us this bicarbonate ion, blah, 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 chemistry that you don't understand and I only barely understand. But what this is where biological organisms make their shells. So that's good. Bicarbonate stored in the long ocean interior as we have these organisms that make their shells and they die and they become part of the geosphere. Yay, happy long-term storage of carbon. Next item. Lab break number 2. What is dry ice made of? Carbon dioxide. Now, if we were in class together today, I would have carbon dioxide and we would have dry ice and we would play with it. What happens to the water with the dry ice in it? It becomes more acidic. You have learned that last semester. I have also linked a video for you in Canvas that goes to the demonstration of where we see the water becoming more acidic because of the carbon dioxide in it. We know this to be true. Water becomes more acidic when there's carbon dioxide in it. Hey guys, that's why soda is going to rot your teeth because it has a lot of carbon dioxide in it, which makes it very acidic. Soda is highly acidic. Now, after we produce the acidic water with the carbon dioxide, with the dry ice, I would have given you little droplets of it. You would have put it onto those shelled rocks I gave you. And here's what you would observe. You would see with your hand lenses, the droplets of the acidic water from the dry ice. You would see tiny little bubbles on the bottom of it. We would also put a drop of regular tap water on there, so not acidic water, and you would not see bubbles, so this would be our control. You do see bubbles here. What did we previously learn that bubbles are a sign of? Well, solid, liquid, bubbles are gas, so chemical reaction. Just as those rocks with the shells in them were being dissolved, that before with the strong acid, that weak acid, this is weak acid dissolving these rocks. The rocks dissolve, they break down when the water is acidic, which brings us to ocean acidification. Ocean acidification is exactly what it sounds like. It is the ocean becoming more acidic. Here's how this happens. People pump more carbon dioxide into the air. The more we pump it into the air, the more the ocean uptakes. Yay, ocean, thank you. But then the more carbon dioxide there is in the ocean, the more acidic the ocean becomes, which is ocean acidification. As that happens, the shelled organisms dissolve. They dissolve and the organisms producing the shells weaken. Here is a chemical reaction explaining how they weaken. Now, I'll be honest with you, Mr. Nowicki could actually explain this to you. I can't. But I want you to know through carbon dioxide reactions with the bicarbonate ion in the water and all this, it produces this two bicarbonate ions, which somehow means that the ions impede calcification, meaning the ions that are produced stop the calcification from being able to happen. So this is healthy marine life shells, somewhat weakened. This is organisms that do not survive. Now, as more of this stuff is dissolved and these shells weaken, that produces more carbon dioxide gas. So there's more carbon dioxide gas in the air, which then is put into more ocean uptake, which makes the ocean more acidic. And we have created a positive feedback loop. It is a positive feedback loop of a negative thing. So this is not good news. So the more carbon dioxide we pump into the air, the more acidic the ocean becomes. The more acidic the ocean becomes, the less things like coral and shells can live in there.